Hey guys, this is Mr. Grice for Algebra Unit 10.3 in-class practice, day 2, even though now it's technically day 3. So, we're on the back side of the notes. The front page looks something like this. So, go ahead and get your graphing calculators out, or just follow along. Let's go ahead and read number 3. It says the table shows the cooling temperatures of a freshly brewed cup of coffee after it is poured from the coffee pot into a mug. Step A says use your graphing calculator to create a scatter plot of the data. So go ahead and get your graphing calculators out. Excuse me. And we got to plug in some data. So first thing we're going to do is make sure these things are selected. As we start to input data, I can see that I've got a bunch of stuff in there, so I'm going to clear all of that. You want to make sure that you're on L1 and L2. And now we can start entering the data. So go ahead and pause the video. We've got a ton of information, so make sure all of your points match. Okay? Good luck. Okay, so after, oh, excuse me. Sorry. Anyways, after we put in all that information, we need to go to Window, and we need to set this, okay? So our lowest number we have is 0. I want to make sure that I can see that part of the graph, so I'm just going to go to -2. Now the maximum for x is 50, and I want to go a little bit past that, so I'm going to go 55. Now my y min, the lowest number for my y was 100.5, so I'm going to go a little bit less than that at 95. And the max is 200, so I'm just going to go a little bit above that too. I'm going to go at 205. So once again, I'm getting all of those numbers based on my x min and max and my y min and max. That's where all that stuff's coming from. Okay? So I'm going to go ahead and graph. And what do we have here? Well, I know for it's not linear because it's got a curve to it, so it's either quadratic or exponential. Well, does it go back up? Is it a U-shaped or more of a J? Yeah, it's a J. So that means that we are looking at an exponential graph. Okay, so we have to round to the 5th decimal to find our equation. To find our equation, we go to Stat. We're going to calculate, and we need to go down till we find EXPREG, the exponential regression, which for me is 0. After I plug that in, we hit calculate, and there we go. Now we have to round this to the 5th decimal. So if you want to pause it right now so you can write down the equation. Remember, when we write the equation, we're going to put the b in parentheses. So I'm moving over to the other screen now. So our equation is y equals 178.83834, parentheses, our b value was 0.98703 to the xth power. Now, is this exponential growth or exponential decay? There's two ways we can tell. We can tell by looking at the equation, by looking at our b value, and we can tell by looking at the graph. Okay, and this is decay. Well, just think about it. If you have a hot cup of coffee and you just leave it there, it's the temperature going to get hotter, or is it going to get colder? It's going to get colder. Okay, and that's the decay. the temperature is decreasing. All right, let's go ahead and look at question D. It says use your equation from part C. Determine the temperature of a cup of coffee after 75 minutes. So this is our X value. We're going to take this equation, paste it, come down here. I don't need that. And our X value is going to be 75. So go ahead and plug that in and tell me what you get. And you can do this on any calculator. It doesn't have to be on a graphing calculator. 178.8384 times 0. I'm just plugging everything in. And we're raising that to the 75th power. What'd you get? Well, that's what I got. 67.17955.121. So, and it says to round to the nearest tenth. Okay. So, I'm going to write down that it was 67.1 what? 7. Okay. So, round up or down? 5 or more, raise the score. 4 or less, let it rest. So we would round this up, which means that y is equivalent to 67.2 degrees Fahrenheit. Okay? So there's our final answer. All right, E. What is the rate of decrease or decay in the temperature of the coffee per minute? So, I don't know if you guys know this, but in class, I referred back to our notes from the previous day. The only thing we need to pay attention to is over here, not the Chinese writing, but this right here. It's decay. So we have to do 1 minus B. Okay? So to find that, in parentheses, we do 1 minus 0.98703, and then we're going to times that by 100. And that's going to tell us what the percent of decay is. Did you get it? I'm not plugging into my calculator. You got to tell me. No, say it louder. I can't hear you. All right, well, I got to get my ears checked. I think that's what you said. 1.297%. All right, let's move down to the next one. It says Michael Jordan is arguably the most renowned athlete of all time. Since his entry into the NBA, the average salary of all NBA players has increased. The table shows the average annual salary of an NBA player in thousands, so make sure you know that's in thousands, for a selected amount of years after 1980. So, once again, you guys are in charge. Put that information into your calculator, and I'm not even going to set the min and max for you this time. You guys have been doing this long enough. So pay attention to the mins and maxes of the X and Y and see if you can figure out. Pause the video and good luck. Okay, so there's my graph. And if you want to see how I set my window up, there's my window. But is this showing exponential, or is this linear, quadratic, or exponential? I kind of just said it. Yeah, it's exponential. It's not a parabola. There's no U shape. And it's not linear. It's not a straight line. There's a curve to it. Okay? So I'm going to go ahead and calculate the line. Oh, domain error. Let's see what I did. Let's go back to stats. And hold on. Okay. Well, sorry guys, but my calculator is having technical difficulties right now. But it is exponential, and the equation that you should get rounded to the fifth decimal is 161.2994, and then 1.16919 to the x power. Okay? So, approximately how much money did an NBA player make in the year 2000? Now, you're not taking the equation and being like, oh, well, x is 2000, so that's what I'm going to put in for x. No. Okay? Remember that we started in the year 1980, so we have to subtract those to find out that we should really be plugging in 20. Okay? And when you plug 20 in, what did you get? Well, you should have gotten that y is 367.8.628. And remember that they're talking about 1,000 right now, okay? So what this number really is 3,678,628. So in the year 2000, that it really wasn't that long ago, that's what the average basketball player was making in 1 year. That's pretty nice. Definitely a little bit more than what I'm making. Okay, and E, find the growth rate of the average annual salary of an NBA player. So I'm coming back over to our notes, and this is telling me how to find growth rate, B minus 1. Okay, so you're taking 1.16919, subtracting 1, and then timesing it by 100. And then you get a growth rate of, drum roll please. What'd you get? I got 16.919%. Okay, so as of right now, every single year it looks like their contracts are increasing by 16%. Way to go, Michael Jordan. Way to hook up those basketball players. All right, now, if you have any questions on this or anything else, please come see Ms. Carranza or myself. We would love to help you out. And that's it for Algebra Unit 10.3 notes or in-class practice, day 2. Thanks for watching.